Hello everyone, welcome to Unit 3, Lesson 3. We're going to be introducing exponents today. So this is also a recap video of what Mr. Rule went over yesterday in the Desmos lesson. So I'm going to kind of recap some of those problems, and these will be very similar to the types of problems that you'll see in the MyOpenMath assignment today. All right, so our goals are pretty simple here. We want to learn how to expand exponential expressions, condense exponential expressions, and evaluate exponential expressions. So you'll notice a difference in those words there: expand, condense, and evaluate. So we want to make sure that we know the difference between those and what they mean, and make sure we understand, like, when we come up on a problem, do we know what it is we're supposed to do? All right. So let's go ahead and get started here. So these first problems, notice that in bold and underline it says evaluate the following exponential expressions. So we have something like this where it says 4, right? 4 being the base raised to the 5th power. That 5 is what we call an exponent. And what that's telling me to do is it's telling me to take 4 and multiply it by itself 5 times. Okay, so really it means 4 times 4 times 4 times 4 times 4. And sometimes we have to do that depending on a scenario or application, but it's really annoying to write it like that. So it's a lot easier just to write it as 4 to the 5th. And if I wanted to evaluate this thing, I'd go to my calculator, and let me pull that up real quick. All right, so I got my calculator here. And if I wanted to evaluate this thing, I could do it one of two ways. I could do 4 times 4 times 4 times 4 5 times, or I can just use the exponent feature of the calculator like this. And it's a lot easier to do that. It's a lot quicker. So that's one of the main reasons that we love exponents. Okay, so we've got 1024, and I'll show you the other way too, right? So 4 times 4 times 4 times 4 times 4, right? And then you get the same thing, right? So you can see the congruence there between those two. So we get 1024 when we evaluate this. So when they do say evaluate, we want to know what this actually equals. We should come up with a final number at the end. All right, so we're going to do it again this time for 6 to the 6th power. So I'm going to bring up my calculator here. I'm not going to even bother expanding it. I don't really need to. I want to make sure you guys understand what an exponent's really telling you to do. So I'm going to go ahead and evaluate, do 6 to the 6th power. So we got 46,656 here. There we go. And you can put a comma there. Don't put the commas in MyOpenMath. You enter in your answers. All right, so this one says negative 8 to the 4th power. Now remember, what this means is negative 8 times negative 8 times negative 8 times negative 8 4 times. So I'm going to bring up my calculator here, and we're going to do this, but I want to show you something, all right? It is very important to make sure that you put it in parentheses just like it's stated here in the problem, okay? So I got my negative 8 in parentheses. I'm going to raise that to the 4th power, and we get 4096. Now watch what happens if I don't put it in parentheses and I do the same thing, right? So if I just do negative 8 to the 4th like that, notice that it's putting a negative in front of it. That would be incorrect, guys. All right, so make sure the parentheses goes around the negative number when you raise it to a power. Okay, so we got negative 4096. All right, and if you remember anything from Mr. Rule's lesson yesterday, you hopefully should remember that anything raised to the 0 power is 1. But if you don't believe me, you can go to your calculator. We can do 117. 117 raised to the 0 power, and you'll see you get 1. All right? So that's evaluating. All right, now expanding is a little bit different. Expanding comes in more handy when we deal with variables. So you'll notice here the bases of our expressions here are variables. They're not numbers, right? But it still means the same thing, right? So p to the 6th power still means p times p times p times p times p times p 6 times. All right, just whatever number it is, even if it's a variable, an exponent is telling you to multiply that thing by itself 6 times there. So this one has an exponent of 3, so this will be b times b times b, right? B times itself 3 times. And then if we do d to the 0 power, well, the only way to expand that is just to write its final value, which is 1. Okay, even if it's a variable, right? It doesn't matter what number it is. If it's being raised to the 0 power, it is just 1. All right. So here we go. Let's go to this next one. This one says simplify or condense, right? So we're starting with an expression that has been expanded and we want to put it back together, right? One of the great features of an exponent is taking something that's really annoying to write and making it easier to write, right? So that's why we call it simplifying or condensing, right? So condensing, like making it smaller, all right? So if I have a times a times a, I have a base of a, and it's repeating its multiplication 3 times, so I can say this is a to the third. All right, and that's a lot easier to write than this, especially if we have a lot of them like this one. Okay, so if I count these up, I got 1, 2, 3, 4, 5, 6, 7, 8 of these things, right? So the base is y, and since it's multiplying by itself 8 times, this would be y to the 8th power. All right, last one here one more time, right? Q is the base. Q is the base, and I've got 1, 2, 3, 4 of them, so this will be q to the 4th power. So that is what it looks like to condense or simplify an exponential expression. All right, multiply. All right, so multiplying. So notice here, I've got two exponential expressions. I am multiplying them together. Also take into account that these both have the same base. All right, so I can do this two ways. I'm going to show you one way with this one. I'll show you a second way with this one. So for this, if we expand first, right? So if I take this y to the 5th and I expand it, and when I do this, I'm going to put it in parentheses for right now. So we got y times y times y times y times y. Right, so there is my y to the 5th. I'm going to start a second parentheses, and I'm going to put my y to the 3rd in it. So I've got y times y times y, right? 3 of them, right? Because the exponent is 3. So I can see both of my original pieces here expanded, and then I can drop the parentheses, so I can just say y times y times y times y times y times y times y. All right, so I've got my 1, 2, 3, 4, 5. Oh, I need one more y. Missing one there. And then now I can just count them up, and I can say, okay, well, that's 1, 2, 3, 4, 5, 6, 7, 8 of them. All right, so we would get y to the 8th power. All right, so I started off with a multiplication of two exponential expressions. I expanded, I removed the parentheses, and then I condensed to get a simpler version of that same expression. So this is just y to the 8th. And you might notice here like 5 and 3, well, those add to get me 8. And that is a pattern. We saw that in the Desmos lesson yesterday. If we are multiplying two things with the same base, we can simply add the exponents. So that's how I'm going to do this one. Rather than writing out these expansions, okay, I'm going to save myself a little bit of time. And I think, well, x to the 4th means there would be 4 x's, and x to the 2nd means there would be 2 x's. So there's going to be 6 x's total. I don't need to write that out. I can just do 4 plus 2 and say, okay, well, this is x to the 6th power. All right, guys, that's it. Hopefully the video helps you out with your practice problems. If you have any questions, let us know in the Zoom chat. Have a great day.